given that you're on this call, you understand there's a problem with passwords. I mean, that's pretty direct. But what I like to use this slide in this part of the presentation, which is your standard security FUD slide, is saying, great, you as security or as IT people understand that you can be phished or farmed using your standard user ID password. What many very proficient security people do not realize is that many of the same mechanisms used to phish and farm username passwords can be used against what is considered secure. And what I mean by that is many people feel that the SecureID and the Vasco tokens and the Verisign tokens, not to pick on any vendor, feel that those products will protect against all types of phishing. And this technically is not valid. What is happening today is very often there are man-in-the-middle attacks. And these attacks simply lure the end user from their browser to a attacker's reverse proxy, which then replays the credentials of the end user. These credentials being replayed, therefore, are just as valid as the original tokens and the numbers shown on the soft or hard token. What needs to be done to actually secure an online transaction is what is called a bilateral authentication. And what we mean by bilateral authentication is that not only is the left-hand side, that is the client, authenticated, but the right-hand side is authenticated as well. That is the server. That is the client has to identify the server. And I'll go into a slide on that. Just to remind what we're talking about, SecureAuth is an authentication product, and it is a non-phishable. That's what I'm talking about, bilateral authentication. It stops the phishing, and tokenless. That is, there is nothing for you, the enterprise, to actually deploy. How it looks, and given that most people probably on this call have IT background, so it always helps to see an image to see how is the SecureAuth solution actually deployed in the enterprise. It's simply this. We have a software module that, to be specific to the Outlook Web Access discussion, can literally be installed directly onto the server itself, the Outlook Web Access server, or it can be placed, which we recommend, on another server in its own security software and hardware configuration. That module is, and this is where it's very advanced, has some very, very unique and exceptional properties. One of the properties is it's able to authenticate a user and inspect the user's platform, that is their browser, and that could be Apple or Microsoft platform, and Firefox or IE or Safari for Apple, is able to inspect the user's browser and inspect whether they have a valid X509 PKI certificate. If that user does not have that certificate, what can be done is utilize our hosted web services and make a secure WSE 3.0 web services call. Now, the hosted 6.9's co-located facilities we have is hosting SMS telephony, SMS text messaging, telephony, one-time passwords, which we'll see in the demo, and also our redundant certificate authorities. What that means for the end users here is that the enterprise only has to install our software module onto a server. The complexity of what I mentioned, the rocket science we call, the SMS text messaging, the telephony, the CA servers, and all that adjoining hardware is hosted by us in our facilities. Now, if you're a Fortune 100 company and you say, Garrett, that would never fly, we'd have to host it ourselves, we are glad to actually, we can install those services at your site as well. The point of all this technology is to have a secure authentication and to create a valid identity. Our ability to push down a public-private key pair on the left-hand side and then authenticate and validate that on all subsequent sessions mitigates and stops the man-in-the-middle attack. Because what this user is trying to do is steal your credentials and then pass them on to the original server. Our product stops this by forcing the authentication server, be it the illegitimate authentication server or the legitimate authentication server, to reveal its identity to the client. And that information is cryptographically signed with a private key and then passed back to the right-hand side, to the original server. And if you're following this and you have some PKI background, you're like, well, Garrett, that's pretty much what PKI and client-side SSL is all about. What are you different? Great. Thanks for being on the call, and that's what I'll do for the rest of the time, is explain why we're different.